In this video, I'm going to be talking about integration by parts, and I want to first derive the parts formula, or just kind of show you where it comes from, and then do one quick example. So, recall from Calculus 1 the product rule for differentiation. So I have the derivative of u times v, two separate functions, is equal to the first function times the derivative of the second plus the second function times the derivative of the first. This is that prime notation I'm using here. So the derivative of a product is first d second plus second d first. All right, I'm going to take that formula that we learned last semester, and I'm going to integrate both sides of the equation. Now, integration is a linear operator, so when I integrate the right-hand side, I can split up the integration into two separate integrals. So I'm just integrating everything. I'm going to integrate the left-hand side, and I'm going to integrate the right-hand side. Now, on the left, I'm integrating and finding the derivative. So these just kind of undo each other for the most part, and I'm left with the product of u and v, and they are equal to the sum of these two integrals, the integral of u v prime and the integral of v u prime. Now I'm going to solve this equation for this term right here, the integral of u v prime. So to isolate this, I'm going to subtract the integral of vu prime to the other side of the equation. Let's see. I've got the integral of uv prime is equal to uv. Now I'm subtracting this other integration. This is the parts formula. I have it memorized not in prime notation, but in the d notation. So I'm just going to rewrite it. The integral of u dv, the derivative of v or v prime, just two different notations for saying I need the derivative of v. That's going to be equal to the product of u and v minus the integral of v, and this is du. All right, so I'm going to kind of box this. We call this the integration by parts formula, or the parts formula. And it's convenient. If I'm trying to find the integral of some product, then I can just use this formula. Now the product is very particular. U represents some function that maybe I can find a du, and dv is some other function that maybe I can integrate and find v. All right, for a quick example, let's do the integral of x times e to the x with respect to x. So this is a product. I have x times e to the x, and I think I'd like to use this parts formula. Now, I highly recommend for the first 50 times you use the parts formula to write it down. So I'm going to rewrite it. Parts formula says the integral of u dv is equal to the product of u and v minus that other integral v du. So I just rewrote the parts formula that I'm about to use. So let's let u equal x, and let's let dv equal e to the x. In the next video, I'll talk about strategies behind knowing which factor to let be u and which factor to let be dv. But I'm going to go ahead and just let u be this first factor x, and dv be this second factor e to the x. Now I am going to integrate this one. So I do need the dx with the integration term. All right. Now notice the parts formula needs a du. So I need to go off and find du, but that's easy. The derivative of u is, or I'm sorry, the derivative of 1x is 1 dx. Also notice that the parts formula needs v. It actually needs it twice. I've got dv, the derivative of v. So to get regular v, I need to integrate dv. So I'm going to integrate e to the x dx. The integral of e to the x is nice and easy. It's e to the x. So the integration uses up that dx notation, and the derivative spits out that dx notation. With those four terms, I'm ready to apply the parts formula. I have the left-hand side of this equation. I think I'll just go ahead and rewrite it real quick. This is going to be equal to u times v. U we let be x, and we just found v to be this e to the x, minus another integral of v, which we just said was e to the x, being multiplied by du, which we found to be dx. Almost like a never-ending problem, and just spit out another integral. But I know this, the integral of e to the x is e to the x. I'm done with the integration process, so I can go ahead and spit out a plus c. And I'm looking at the answer. Technically, I guess if we wanted to be fancy, we could factor out an e to the x. I'm going to go ahead and box this before I lose it. I don't know if this is helpful or not, but technically we could say this is e to the x times x minus 1 plus some constant. That's another good form of the answer. And in the next video, we will show a lot more examples of integration by parts. See you then.